Hi and welcome. I'm trying to learn mechanical engineering, today the seismograph, and after we've done it, we're going to do martial arts basic training. And if you participate in the martial arts basic training, then it's the at your own risk. The seismograph. The seismograph or seismometer is an instrument for recording the waves produced by earthquakes or man or human-made explosions. Okay. Now an earthquake. By an earthquake where the whole earth consists out of many big plates, and on top of it there are humans basically living, and also the animals. And these plates are moving a little bit, like plates, like ships in water, basically, like they're sometimes pushing against each other, or also pulling at each other. And they're basically sticking together all the time, and then suddenly they move a bit. So with a lot of force, it's 1,000 kilometers big, the whole continent, and suddenly they move. And now this sudden movement is known as an earthquake. And on top of that plate, humans can feel that as an earthquake, and it can be also dangerous. And a seismometer is there to measure it, are we told here. Instrument for recording the waves produced by earthquakes. So it goes in some little things or whatever. And this has been recorded by a seismometer. And also explosions. Explosions also make a little vibration to the whole surroundings. And the seismometer or seismograph can measure it. It works on the principle that a frame rigidly fixed to the earth will react to a shock much more rapidly than a heavy weight attached to a frame by a flexible support such as a spring or pendulum. Now, thankfully, through these two pictures, we understand it. They are saying, if there's a fixed thing standing on the ground, a leg, it will immediately feel the movement. But the arm in the air does not feel it. So you get the feeling directly on the foot and on the leg, but the arm's mostly completely still. Now the idea is that the foot is directly moving, but not the arm. And there's a difference now. And this difference, that the leg moves a centimeter to the side, but the arm is basically not moving, that difference has been measured with a seismograph. Seismographs are designed to measure either vertical or horizontal movements of the earth. Now let's try to go to the two pictures and understand that. Now, heavy mass remains motionless while all other parts move. Base moves in a horizontal direction. Where the whole thing which is standing on it can move to left or right through the earthquake, but the thing in the middle does not move. This is fixed in the middle, through something fixed, I think. And now there's a paper, and whenever that whole thing moves, but not the block in the middle has a pen onto it and writes it on a piece of paper. So that whole thing is moving from left to right, and the pen is writing on the ground. And now the other one, base moves in vertical directions, so the base can also go up and down, and heavy mass remains motionless while all other parts move. Now our heavy weight is now on a coil? I don't know what they call it. On something which is... And now, because of that thing stays basically in the same position. Like a car, the thing which a car... It's coil spring, it is a coil. And now, basically the whole thing moves, but not the part in the middle. You have a graph. And now the whole mechanism moves, but not the thing in the middle. Like a car, just the tire moves in and out, but the car stays mostly stable. So that the people in it not become everywhere up and down. And now this thing in the middle stays stable, but the paper roll is fixed, and now that whole thing goes up and down, that whole machine, and the thing in the middle writes then onto the paper. And these things were then clear for the people. There was an earthquake. Maybe someone bumped against the table. Maybe there was an earthquake. Okay, that is how seismograph works. Now, we are just 4 minutes in. The question is, am I able to make right now the presentation about it? I think yes. There are two types. The ones that go in vertical directions, and there are the whole... I don't know the words for that all in English. The whole setup, the whole machine moves, but so a heavy weight in the middle stays stable with the pen onto it. The machine moves and goes against it, and the other one, the whole machine goes to the side, but there's a thing in the middle, fixed with block, with heavy mass stays in the middle, and writes it on a piece of paper, which goes with the whole machine from left to right. That whole measures when, because the the vibration movement, the seismological activity of the Earth makes first on the heavy object. Let's see it again. It works on the principle that the frame rigidly fixed. It means rigidly. Frame rigidly fixed. To the Earth will react to a shock much more rapidly than heavy weight attached to a frame by flexible support such as a spring or pendulum. Okay, the one thing is a pendulum. It's just a pendulum. I was thinking about how it works. If I had something in the middle that block stays in the middle or something. No, it's just a pendulum. Okay, maybe the other one is a coil. So these are spring and pendulum. I'm going to call it out spring and pendulum. Okay, what is up the same camera? I have it's time for 2-3 takes. I'm going to start it up. But first, this is one, Earth and its resources. I want to say who wrote that. Earth and its resources. So 1, part 2, and that is written by John Gribben, PhD, FRAS, FRMETS, visiting the Fellow Science Policy Research Unit, University of Sussex, that's in Britain, and Peter J. Smith, BSc, PhD, FRAS, Reader in Earth Science, The Open University. Wherever that is. Maybe that is nowhere in the place. Okay, and according to, now there will be John Gribben and Peter J. Smith. Okay, I try to say seismographs or seismometer. They are there to measure earthquakes or big explosions. And they work on the principle. So what first how it works. There's a rigidly fixed frame. It is basically a setup. And in it there can be now something hanging on a coil, on a spring. And now if the Earth makes movements from up and down, then that whole frame which is fixed in moves up and down. But the heavy weight in the middle onto the spring is not moving so much. And now that whole thing is moving, but the thing in the middle stays basically on the same thing. The whole frame moves, but the thing in the middle stays on the on the coil hanging. And the other setup is to measure horizontal movements. There's a pendulum in the middle. So the whole setup moves from left to right, and in the middle there hangs a pendulum, and the pendulum stays all the time the same to the Earth, basically. And now the principle is that the Earth basically has first the force onto the rigidly fixed thing standing onto it, and only later on and only a little onto the weight, the massive weight hanging freely. So the coil is absorbing the shock going up and down, the frame moves but not the heavy weight in the middle, and the other one with how thing moves but the pendulum hangs all the time basically like that. And now it works when at the pendulum there's a pen basically, and it writes then onto a piece of paper lying on a fixed frame. So the pendulum hangs here, and the frame moves, and then it makes these lines. That would be the pendulum, and I think it would be the coil, and the pendulum will be the other way around, that it goes from side to side or something like that. And that is according to the Reader's Digest Library of Modern Knowledge, book 1, part 2, written by John Gribben and Peter J. Smith. I forgot the wrong page. Now what was it? It was the pendulum was making horizontal, and the coil was making vertical. It wasn't relating to the side, it was but it doesn't matter. I'm going to stop the second camera. And we have made our first part of mechanical engineering, and also our first video about something. Now, that was the mechanical engineering part. If you were here for mechanical engineering, you can go directly to the next part of mechanical engineering. If you stay here and participate in the martial arts basic training, that is with your own skill. The standing hold, bring one leg up and pointing with the toes down. And the other leg. Pull the knee up. And now take the leg to the ankle, make a straight back, and point with the knee down to the ground. And the other leg, take the leg at the ankle, make a straight back, and point with the knee down to the ground. And the next exercise, over to one side, the toes are pointing forward and we're stretching the inner side of the leg. And over to the other side, again with the toes forward. And on the mantis, go from side to side. And now, stand good and bring one knee up and back, make 1, 2, 3 steps in the middle, over to the other side. The shovel snowplow. And one more time. And now stretch kicks. One arm out, and kick against it. 3 steps in the middle, kick against the other one. 1, 2, 3, and kick. And 1, 2, 3, kick. 1, 2, 3, kick. And 1, 2, 3, kick. And now the frog. Knee up and back, and again up and in. The other one. Up and back, up and in. Again. And now crash can kicks. Kick up and back, up and in. The other one. Up and back, up and in. Again. And now lunge kicks. I'm going to kick now close to the camera. So first the lunge focus with the left leg, and then kick in front and back again. Now with the right leg in front and kick again. And back. And left leg in front, down, and kick. And again. Now last round, right leg and kick. And left leg and kick. And now squat kicks. Down to a squat, up and kick. You can do also a wire squat. Down and kick. Down and kick. Down and kick. Last two. And now, I don't have the name, squat circles. Down into a squat and then over kick. Down into a squat and over. Down and over. And again down and over. Last two. Down and over. And now swing kicks. Swing over and over. 1, 2, 3 steps up. Over. 1, 2, 3. Up and over. And last 1, 2, 3. And over. And now 12 push-ups. Finger onto the ground, arms underneath the shoulders, and down, elbows close to the rib cage, and a straight back, tuck the tail under the torso. First one and the second one. And number 3, and 4, 5, and 6, and let's do 7, and 8, and now to number 9, and 10, 11, and to the last one, number 12. And now hiker sit-up, stretch your heel onto the ground and pull the toes in. Put to the left and pull the toes in. To the right, pull the toes in, into the middle, and move the leg from left to right. Other heel onto the ground and pull the toes in. To the right and pull the toes in. To the left, pull the toes in. Middle and move the leg from left to right. And knee again up. Other one up. Legs wide apart, breathe finger down. And out again down. Again in. And out. Breathe in, close the legs. And breathe in, out. That was the martial arts basic training. I thank you very much. Until next time.